lot of steps with chapter 3.
There are a lot of steps in chapter 3.
My Spidey's.
We're going to break it into 2 tests for chapter 3. Okay, 3.1. We're talking about solving linear systems by graphing, okay? This you should be able to do, linear systems, yes? Okay, if I want to graph these 2 linear systems, what do I need to do first?
Y by itself.
Get y by itself. So what does this blue one turn into?
Y. Negative y. Y equals negative x equals 8.
Plus 8. Yep.
Nice.
What does the pink one turn into? This has multiple steps. I'm going to subtract 2x, right? I get negative 3y equals negative 2x plus 18. Then I have to do what?
Divide by 3. Negative 3.
Divide by negative 3, so y equals 2/3 x. And what's 18 divided by negative 3?
Negative 6.
Okay. Now I'm going to graph these 2. To solve this system, I'm going to graph them and see where they overlap. Okay? So,
Yeah, I remember.
the blue one starts at 8. So I'm going to count by 2s. So 2, 4, 6, 8. Okay, we'll just label this as 2 so we know. And it goes down 4 over 1, correct? 2, 4, and then 1 is halfway between. Maybe if I put it on a line, that'd be smart. Okay. And then it goes down 2, 4, and over 1 again. Okay. There's my line. So that I can graph this a little bit more accurately. Okay, so there's my line. That's the blue one. Now, the pink one, we said, starts at negative 6, so 2, 4, 6, and it goes up 2 over 3, right? Up 2 over 2, 3. Up 2 over. Okay.
Can I grab the third book real quick?
Yeah.
For a minute?
So I started the second one, so good.
I know, right?
Okay. So I probably need to extend this blue line a little bit more. So my solution point is going to be where these 2 graphs cross. Okay, so my solution point is right here. Now that point on this graph should be what? 2, well, I can't tell exactly how. Because my graph isn't perfect, it's going to be a little off. But for your homework, make sure you use graph paper. So my solution point should be 3, negative 4, which is really what it should halfway between 3, negative 4. Now, if I want to check my answer, I'm going to plug 3, negative 4 back into each equation to check and see if it comes out to the right thing. So when I check, I plug 3, negative 4 in here. Negative 4 equals negative 4 times 3 plus 8. So negative 4 equals negative 12 plus 8. What's negative 12 plus 8? Yep. So that one checks out. I plug 3, negative 4 in here. I get negative 4 equals 2/3 times 3 minus 6. 3 times 2 is 6. 6 divided by 3 is
2.
So 2 minus 6 is, so negative 4 equals negative 4. So that is my solution point. So when you graph these, you're going to then figure out what your solution point is. On some of them, if there are fractions or things like that, you're going to give me a rough estimate, and I'll count it right if it's like close, you know, because like on my test for Algebra 2 the other day, we had one and the solution point was like negative 3.7 and negative 4.2. So if they put 3 or they put negative, if they put negative 3 or negative 4, I counted it, okay? Because it's hard to tell when you're graphing it by hand. What?
How did you graph that then?
I graphed this line. I did my y-intercept and then I did my slope. So my y-intercept was 8, 2, 4, 6, 8. My slope was down 4 over 1, down 4 over 1. So you're just graphing them like you graph lines. Okay, so that's the first part of this, is graphing 2 lines and finding where they meet, where they cross, and telling me what the solution point is. In your book, you're going to have to plug that solution point in, plug it back in, and double check it like we did in the black. Okay? That shouldn't be anything new to you. Okay? Graphing lines shouldn't be anything new. So if I were you, even on your homework, I might use 2 different colors so you don't get confused, whatever you want to do. Okay? Then we have 4 types of things we can classify something by. Well, really 3, but we're going to talk about that. If a graph is consistent, it has at least one solution. Like over here, this is a consistent graph. It has at least one solution. Okay? If something is inconsistent, it has no solution at all. If something is independent, it has exactly one solution. So what they're going to do is they're going to call it consistent and independent if it has one solution. And if it has infinite solutions, they're going to call it consistent and dependent. Okay? This is an example, or this is an example of a consistent and independent solution. Okay? It has exactly one solution. It crossed exactly one time. It's consistent and independent. Something that's consistent and dependent means that they're going to have the same slopes because they are going to be the same line. So every point on here is graphed on both lines. Okay, there's technically 2 lines in this one arrow. Something that's inconsistent are going to be lines that are parallel because parallel lines never cross. So there's not going to be a solution. Okay. So then I have 2 other sets over here where we're going to graph these and we're going to classify them as consistent and independent, as consistent and dependent, or as inconsistent. Okay. So, how would I start by graphing these? What do I need to do? Get y by itself. So over here, I would have negative 3y equals negative 4x plus 8. Then what do I have to do? Divide by negative 3, and I get y equals 4/3 x minus 8/3, right? Which you can turn into decimals. We'll do that in a minute. If I graph that, 8/3 is what? 2 and 2/3, right? I think 8/3 is 2 and 2/3. If 8/3 is 2 and 2/3, then I start that as my y-intercept, negative 2 and 2/3. Okay. So negative 2 and 2/3 is somewhere around there. Then I'm going to go up 4. 1, 2, 3, 4, and over 3. 1, 2, 3. Now do you see why I say it's important to use graph paper that's like accurate, because you're going to be doing lots of graphing. It needs to be accurate. Okay. There's that. Now, let's change this pink graph. So the pink graph would say negative 6y equals negative 8x plus 16. I divide by negative 6, and y equals 8 over 6 reduces to 4/3, right? Mm-hmm. And then 16 and negative 6 reduces to negative 8/3. Ooh, what do you notice about that? They're the same. So this is going to graph right on top of here, right? So what happens if they graph like that? Consistent and dependent. So I would classify these as consistent and dependent because they rely on each other, okay? Consistent and dependent. So on the next one, okay, what do I need to do before I can graph these? Get y by itself. So this one's going to say y equals negative 2x plus 4, right? And this one's going to say y equals negative 2x plus 1. Correct?
Mm-hmm.
Okay. So, what do you notice about those equations right away? They have the same slope. So what does that mean they are? What type of lines?
Parallel.
They're parallel. If they're parallel, what does that mean they're classified as?
Oh.
Inconsistent.
So do I even have to graph those if I can recognize that?
No.
No. So if you can recognize that these slopes are exactly the same and they are parallel, you can just write inconsistent and save yourself time. Does that make sense? If you can recognize that these have the same slope and the same point, you don't have to graph it either, okay? So this one here is inconsistent. If I graphed it though, okay, it would look something like this. I would go to positive 4, and I would go down to over 1, and I would graph that line. Okay.
I have a question. What? Am I able to finish my
Yeah, right now.
possibly?
Yeah. Okay.
I will be right back.
And then the other one would be positive 1, and you can go down to over 1, right? And these lines are going to end up being parallel to each other. Okay? Once again, when you have it on graph paper, it's going to look more accurate because you're not sketching your own graph board. Okay? So if you, here's the key, if you're just classifying and you can recognize this and this from the beginning, you can recognize that these are the exact same equations. You can save yourself some time and not have to graph. Okay? You can just tell me it's consistent and dependent. If you can recognize that they have the same slopes, but their b is different, their y-intercept is different, then you can save yourself time and just tell me what they are as well. Okay? So you don't have to graph these two if you can recognize it. If you struggle to recognize it, graph it, and then you'll know. Yes.
So consistent and dependent is when it's exactly the same.
Consistent and dependent is when it's exactly the same, yes.
So if it's
What if
either of
it's-
those, that means it's automatically consistent and independent.
So if it's,
If it's
yes,
not,
if
doesn't have
it's,
the same slope.
right, if it doesn't have the same slope, and if it isn't exactly the same equation, then it is consistent and independent. Yep, you are correct.